Upon installing the program, you will be directed to the sign-in screen. Enter the appropriate information in each field. Your first and last name are required, as is the company name. The email address entered is used to send copies of your weight and balance. There is no need to modify the database field, as this is set by CAVU. Press Submit. A message assuring that you have been successfully registered will appear. Follow the prompts to install the appropriate database. Initially, the demo database will install. If you have purchased an actual database, notify CAVU by email or phone that you have successfully registered your device. CAVU will activate your device for the proper database. Once activated, you may simply press Submit again to install your database. Once the database is installed, the main screen will appear, though a number of selections are disabled. Touch Select Aircraft. A list of the aircraft in your database will appear. Select the aircraft you desire. The performance and weight and balance specific to that aircraft will load. The tail number of the current aircraft will now appear in place of the Select Aircraft button. To change aircraft, simply touch the tail number and select another aircraft. Though the basic empty weight and CG have been pre-installed for each aircraft, you may update the values. From the main screen, select Setup. Here you will see confirmation of the database you are connected to and the current version number or build number. Within the middle section, you will see the current BEW and CG. BEW is defined as the basic operating weight minus the weight of the crew. The values can be changed by touching the number. A keyboard will automatically appear. An X adjacent to the number clears the entire number. Press Done on the keyboard when finished. Changes made here only affect your device. You are encouraged to notify CAVU of the change so the online database can be updated in case of reinstalls. The Cargo Only toggle turns off the passenger seat screen. The current selection is shown with a dark blue background. Re-downloading the online database can be accomplished by pressing the Download button in the lower section. To reopen the sign-in screen, touch Sign In. Otherwise, return to the main screen by touching the Main button in the upper left corner. A common question is, which to perform first, weight and balance or performance? The answer is really one of personal preference. The one approach is to start with a preliminary performance calculation to get an idea of any weight restrictions in play. Then run your weight and balance with this restriction in mind. Once the passenger, baggage, and fuel loads are set, you can accept the weight and balance and return to the performance section where your actual takeoff or landing weight and percent of MAC will be preset into the calculation. The calculations of performance can be readily broken into three parts: collecting the weather and field parameters such as runway length, determining the departure or obstacle requirements, and lastly setting the aircraft performance affecting systems. Each of these parts is accessible by a button on the main screen. Commonly, field conditions is a starting point, so we'll start there by touching that button. When you enter the field conditions screen for the first time, all the fields, with the exception of the barometric pressure, are empty. You may manually enter data in each field or use the installed airport database. To use the database, touch the airport button at the bottom of the screen. When the screen appears, use the scroll section or enter the four-letter identifier of the desired airport. If you desire, you can save the selected airport as the default airport by pressing the Make Default button. This airport will automatically load on subsequent visits to this page. If, for instance, you always want the scroll list to begin with Canadian airports, enter the letter C and press the Make Default button. Once an airport is selected, the runway list will fill with available runways. Adjacent to the runway number are the takeoff and landing distance available values. If there is internet connectivity, the current METAR will display below. Use the METAR to determine the correct runway. Select that runway by highlighting it. You can view U.S. charts by pressing the NOS button at the bottom of the screen. Press Accept in the upper right-hand corner when you are satisfied with a selection. The Field Conditions page will reappear. Notice that when winds are calm, the wind direction, speed, and runway numbers are left blank. If winds are reported, these fields are filled so that the headwind component can be calculated. As always, you can manually enter or overwrite any field. To enter barometric pressure in hexapexel or millibars, simply enter the value in the barometric pressure field. It will be automatically converted to inches of mercury. The blue button beside Conditions can be toggled by pressing it. Available runway conditions will appear. Not all conditions are available for all aircraft types and phase of flight. The keyboard must be lowered in order to proceed. The Next button in the upper right corner will appear in blue. Touch the Next button to continue. Departure requirements is one of the most misunderstood subjects in aircraft performance. To supplement the information given here, we highly recommend the book Aircraft Performance, Myths and Methods, available on the CAV website. Notice the blue button at the top of the screen labeled DP, ODP, SID. This button controls the basis of the climb requirement. There are two choices, a TERPS or PAN-OPS type departure as shown, or a known obstacle which can be toggled by touching the button. When a known obstacle is selected, the user can enter the height and physical distance to the obstacle. This is automatically converted to a net gradient. If a bank angle greater than the manufacturer's maximum bank angle for a net takeoff flight path, or 15 degrees, is anticipated, toggle the switch to Yes. Again, the blue selection is the active position. Conversely, if the user is anticipating compliance with an ODP or SID, this should be the displayed selection. The published climb gradient information needs to be entered. This information can be easily found on the departure plate or minimum section. Notice here that 370 feet per nautical mile up to an MSL height of 7,100 feet is the published gradient for the runway selected. Enter these values in the two top fields of the screen. Automatically, the net gradient at the bottom of the screen, or Obstacle Identification Surface, OIS, is calculated. It is against this value that the performance calculations will be optimized. Notice that there is a switch labeled DP Safety Margin. This switch allows the pilot to compensate for old TERPS and new TERPS departure construction. Original TERPS and PANS-OP procedures are used throughout Europe and are the type most commonly known to pilots. Under these rules, the departure begins at 35 feet above the runway surface, and the safety margin is a constant 48 feet per nautical mile, or 0.8%. When this type of departure is used, there must be allowances made for the close-in obstacles by raising the runway end crossing or reference height from 35 feet to 70 feet. The OIS, or net gradient, is then easily established by simply reducing the published gradient by 0.8%. If the departure procedure was constructed under new TERPS, then the gradient begins at the runway surface, and the safety margin is a percentage of the published climb gradient. That percentage is 24%. In our example, the safety margin would thus be 89 feet per nautical mile. If the 0.8% factor were used on a newly constructed departure, the obstacle identification surface will not be accurately depicted, and the resulting calculations will be overly conservative. So how do you determine if the departure is 0.8% or 24%? All departures not created by the FAA are 0.8 types. Within the U.S., it's a mixed bag. Roughly 60% are new TERPS. The pilot needs to examine the departure plan, a step he or she is already doing, to determine the telltale signs of new TERP procedures. Whether you are looking at the text or graphical depiction of the departure, new TERPS departures will contain a list of obstacles with the distance from the end of the runway, a distance left or right of the center line, and a height for each. If all three components are there, the departure is a 24% type. There is much more on this and other subjects within the book, and again we highly recommend that you look into acquiring a copy for yourself and your crews. Press Next to continue. On this screen you will notice an upper and lower section. The upper section contains flight phase, flap, and subsystem toggles. The description on the button describes the currently selected setting. By touching the Flight Phase button, takeoff and landing calculations are loaded and the parameters below change to reflect the phase. Note when the landing phase is selected that there are landing assessment and landing factor switches. The landing assessment, designed to comply with the Landing Assessment Advisory Committee recommendations, the actual landing distance is multiplied by 1.15. For aircraft without published wet runway landing distance charts, this toggle would also be helpful. The landing factor allows the user to view unfactored and either 60% or 80% factored landing distances. For example, if 60% is selected, the resulting landing distance must be longer than the most favorable runway to comply with 135 requirements. No matter what the phase of flight, flap settings can be selected. Only flap positions appropriate for the phase of flight are displayed. The subsystem toggle differs by aircraft type. In the parameter section, many values have been pre-filled by prior entries. The percent MAC in our example is 0 because the weight and balance has not yet been completed. Likewise, the gross weight is preset to the max gross weight of the aircraft. Once the weight and balance is run, the actual takeoff or landing weight will fill this area. You are allowed to manually override these values if you desire. Once again, the switch's current selection is blue and the keyboard must be lowered to continue. Press Next to calculate the charts. The first thing you may notice when the results page appears is the presence of red values. Red values indicate something may be wrong, and it is your job to get rid of the red. The presence of a red weight indicates that the weight entered on the previous screen was too high. The red value itself is the most restrictive weight. The presence of blue values indicate other restrictions, but not the most restrictive. The V speeds will be based on the most restrictive weight and thus are red also. If the user returns to the prior screen by pressing back in the upper left corner of the screen and changes the weight to a value equal to or below the red value, or changes other parameters to more favorable conditions, the red values will disappear and the V speeds will be based on the actual takeoff weight. Note also that the trim setting is shown as invalid. Invalid entries are calculations or input entries that fall outside of the limits of the chart. Do not be concerned with max weight climb values that are higher than the max weight of the aircraft. Since this is a certification value based on density altitude and not structural limits, many manufacturers display the full value, possibly anticipating a weight increase for the airframe. Also note, max weight climb has nothing to do with the climb requirements for a given obstacle or airport. Press the main button on the lower left screen to return to the main screen. Now that we have an idea of our performance weight restrictions, we can determine load limitations. Press the weight and balance button to begin. Take a moment to identify the different controls on this screen. On the top there are 4 tabs, each with a check mark and a description. The first one, named Passengers, is selected. We will work through the other tabs shortly. On the passenger screen, there are a group of blue buttons along the bottom of the screen. The top row identifies the passenger type: M for male, F for female, C for child, and pounds for actual weights. The E button is for emptying seats one at a time. The seat layout for your aircraft is provided to CAVU for creation. Arms for each seat are embedded in the program. To place passengers in the cabin, select the type, in this case a male, and then touch the seat they are sitting. To place a female, select the F button and continue touching seats. The male, female, and child weights are preset based on winter and summer standard weights. The current season is shown in the lower row and can be toggled. These values can be changed by contacting CAVU. If an actual weight is desired, press the pounds button. Enter the weight within the box that appears on the row. Select a seat to apply the weight. Aircraft can have multiple layouts, such as medevac. If present, the alternative layouts can be toggled by repeatedly pressing the configuration button. New BOW and CG values are automatically loaded for that arrangement. The Clear button empties the entire aircraft of passengers. To enter crew and bags, press the checkmark tab above. As stated before, the crew weights are not included in the BEW. Instead, they are displayed here for easy alteration. Baggage compartments are listed below the crew. When satisfied with the entries, press the checkmark tab named Fuel. The Fuel tab contains separately identified fuel tanks and their maximum weight limit. Enter the amount of fuel on board. If you enter a value beyond the maximum, it will turn red. In the lower section, reserve fuel and taxi burn values are default values. They can be overridden. The reserve fuel is the amount of fuel desired upon landing, and the en route fuel value should reflect the anticipated fuel burn for the flight. In this example, I have purposely entered a conflict situation where the reserve fuel cannot possibly be met. Press the Manifest tab when ready. As you will notice, both the takeoff and landing fuel weight are red, indicating a problem. If I return to the fuel section and correct the situation by adding more fuel, the red entries will turn black. Note also that the passenger count, as well as their collective weight, is shown. As the CG limits are not exceeded within the center of gravity section, they too are black. If they exceed the CG limits, they will turn red. The graph below accurately depicts the fuel burn-off CG shift during the flight. 3 dots will appear labeled T, L, and Z for takeoff, landing, and zero fuel. Aircraft that only calculate zero fuel CG do not display this curve. To send the weight and balance by email, press the button in the lower left corner. The weight and balance as it will be sent appears on the screen. Enter the names of the crew in the appropriate boxes. A space is available to enter a route and leg number. The date and time are automatically entered, as is the subject line, which includes the tail number of the aircraft. The default email address is the email entered on the sign-in page. Once set, this email address can only be reset by CAVU. There are options to set email and CC addresses by aircraft type. Contact CAVU for more information. When Send in the upper right corner is pressed, the email is sent through the device's mail client. A copy of the sent email is retained there. If you desire to not send the email, or you wish to just save it, you can press the Cancel button on the upper left corner of the screen. There you will have the opportunity to delete or save the weight and balance. The saved copy is located in your mail program of your device. A confirmation page is displayed showing what you did. Press the Back to Weight and Balance button in the upper left corner to return to the manifest. Press the Accept button in the upper right corner to transfer the weight and balance information to the Performance section. As the weather and departure requirements have not changed, jump directly into the performance calculation by pressing Performance. Notice that the % MAC and weights for takeoff and landing have been automatically transferred from the accepted weight and balance. Simply press the Next button in the upper right corner to run your final takeoff or landing numbers. Notice that the trim setting has now been calculated and that all the numbers are black. If numbers remain red, you must return to previous steps to determine where the overweight situation exists. Another area of performance that causes a great deal of confusion is the incorporation of a level-off or acceleration segment. EFB-Pro calculates a level-off height as a temperature-corrected value. The importance of this is that we are talking about altitudes only hundreds of feet above the ground. High to low, look out below takes on a new significance under these narrow margins. The value displayed is a briefable, what you should see on the altimeter value to initiate the level-off procedure. But why do we calculate a level-off altitude? After all, there are many calculators and training institutions that simply ignore this procedure. Everyone would agree that in order to replicate the values in the AFM, the aircraft must be flown in a specific manner, an exact profile if you prefer. That profile is called a net takeoff flight path profile and is described in every Part 25 and many Part 23 aircraft flight manuals. All manufacturers have elected the net takeoff flight path procedure of climbing to some altitude, leveling off, cleaning up the aircraft, accelerating to the final climb speed, reducing power to max continuous, and then resuming the final or en route climb. Simply put, if the one-engine inoperative procedure does not utilize this methodology, and you simply rely on maintaining second segment configuration indefinitely, any performance numbers derived from the AFM are meaningless. It is the complexity of calculating this geometry to stay above the obstacle identification surface that makes EFB-Pro so extremely valuable to you, and the reason simplified tab data, FMS values, and airport familiarity do not work. From the main screen, press the Resources button. Initially, the screen will look like this. The buttons on the left side are preset to online resources that provide a vast array of current information. On the right side, there are 6 programmable buttons that can point to online sites, such as your company website. To program these sites, press the Set Up User Links button on the lower left side. This will highlight the 6 programmable buttons on the right. Select the button you wish to alter or set up for the first time. Fill in the description you want displayed in the top field and the full URL in the lower field. Keep in mind there is limited space on the button face. Press Set Button when finished. The button labeled Documents opens a table of contents. Each line item refers to a unique document installed on your device. These are not online resources, thus can be used for checklists and the like. Note that there is a Close button at the top of each document to return to the Resources screen. To set up your company's specific documents, contact CAVU to learn how to transfer these documents to the CAVU server to be saved to each of your devices by simply pressing the Download button in the Setup section. From the main screen, press the FBO Facilities button. Enter a 4-letter identifier for the airport desired. Scroll down or use the pinch gesture to zoom in on data sections. Note there is a Close button at the top of the screen to return to the main menu. Likewise, press the Weather Reports button to obtain current weather worldwide. There are several ways to display information. By entering a single 4-letter identifier, the METAR and TAF for that airport will display. Again, use the pinch gesture to zoom in on the screen. You can also enter multiple identifiers separated by a space as shown, or get the entire state by entering an @ sign before the state abbreviation. That concludes the tutorial for EFB-Pro on iPad. We hope you found the information useful. Again, we recommend the book Aircraft Performance, Myths and Methods. In print format, you can get it with pre-drilled holes to fit inside your Jet Chart binder. And e-book versions are available for Kindle, iPad, or Nook. Thank you for selecting CAVU companies.